Once a fire has started and there is a sufficient fuel and oxygen to sustain it, there are three recognized ways in which it can spread within the building. The three ways are the convection, conduction, and radiation. And there are also the effects of the direct burning and the heat transfer to take into account. First way we have to discuss is the convection. Due to its properties that hot air rises, this can be seen graphically when the smoke from a fire rises and disperses within the atmosphere. The convection process begins when the combustible materials are subject to excessive levels of heat and they give off vapors which in turn ignites. When these vapors are heated, they expand and become less dense than air, and as they rise they leave an area of low pressure, which is replaced instantly by a cooler unheated air. This fresh air is then mixed with the vapor and heated, assisting in the development of greater temperature. And get to know that this process is cyclic, as it continues to support the fire process. Also, convection is the most common cause of fire spread within the building, and during a fire the hot gases and vapors will rise vertically through the stairwells, lift shafts, and service risers to the highest level available. Then they form a layer at that height, from which they spread out horizontally until it checked. Also, as the temperature of the smoke and the toxic gases and vapor layer increases, heat is radiated back downwards and may ignite other combustible materials. Good to know that there is a substantial difference in a fire starting in a confined area such as a building in comparison to that one starts in an open air, and this issue will be addressed when designing building that minimize smoke and fire spread, enabling people to escape safely. There is a direct link between the convection and the effect of the smoke. Although it's important to restrict the spread of fire within a building, it's equally important to consider the speed of spread and the effect of the smoke created by the fire as it burns. And as a fire develops, it will create large quantities of smoke, which will usually spread ahead, filling a building. And the effect of this is to present a toxic and asphyxiant hazard to people within the building. Smoke also reduces the visibility and obscure escape routes, and smoke can lead to or increase a panic, which in turn leads to disorientation, reducing the chances of escape safely. Next way is the conduction way. Conduction is the movement of heat through a material, and the ability of conductors to transfer heat varies considerably according to the type of the material. For example, metal is much better conductor than brick, and it should be noted that the conduction may occur in solids, liquids, or gases. And the thermal conductivity varies between materials and is the key element in building design and construction. And a fire in one room can spread to adjacent room by heat being conducted through the fabric of the building, especially via metal pipes frames used in building construction. And the heat can then ignite materials in direct contact with the surface or radiate out from the surface, and this can raise the temperature of the material in the adjacent room to their spontaneous combustion temperature, thus spreading the fire. Third method we have is radiation. Radiation is the transfer of heat energy as electromagnetic waves, and it doesn't require any contact between bodies and move independently of any material in the intervening space. Also, if it's not absorbed by a fire-resistant material, the electromagnetic radiation can radiate through glazing, causing fires to spread and involve a number of rooms, as with the example of a heater or an open fire. Last point in this lecture is direct burning. When a combustible material comes in direct contact, there is a physical transfer of heat from the ignition source to the material, which in turn releases vapor, which ignite and propagate the fire. And it's true to say that the direct burning makes use of one or more of the previously discussed methods of heat transfer. However, it's appropriate to mention this method as a reasonable proportion of fires are started in this way and when heated to an ignition temperature by coming into contact with a burning material causing fire to spread. Here's the end of this lecture. Thanks for watching and see you later.